This video will look at transfer test questions on the topic of probability, and all the questions have been taken from past papers. Mr. and Mrs. Luce have 5 children. Their first names are given below in order of increasing age. Alex is the youngest and Marie is the oldest. Look at Alex, Alan, Ben, Jane and Marie. One of the children is picked at random. Look at the 4 outcomes below. Outcome A, Alex or Jane is picked. Outcome B, someone older than Alan is picked. Outcome C, someone whose name begins with an A is picked. Outcome D, someone older than Alan but younger than Jane is picked. Which outcome is least likely? Circle A, B, C or D below. Well, if we look at the first outcome, the chances that Alex or Jane is picked. So there are 5 children in total, and 2 of those are Alex or Jane. Outcome B, someone older than Alan is picked. Again, there are 5 children in total, and there are 3 of them older than Alan: Ben, Jane and Marie. Outcome C, again there are 5 children, so someone whose name begins with an A. Well, we've got Alex, Alan, so there's 2 of those. And outcome D, someone older than Alan but younger than Jane is picked. So older than Alan could be Ben, Jane or Marie, but the same statement says that they have to be younger than Jane, so there's only Ben. So which outcome is least likely? Well, if we look at our numbers and our statistics now, the probability that A happens is 2 chances in 5. The probability that B happens is 3 out of 5. Probability that C happens is 2 chances in 5. And the probability the statement D happens is 1 chance in 5. So it is least likely. If I wanted to look at the numbers in terms of a percentage, 2 chances in 5, well, 1/5 is 20%, so 2/5 is 40%. 3/5 would be 60%. 2/5 again, back to our 40%. And 1/5 is 20%. So we can see that the 20% is the lowest chance of happening, and again it is outcome D. Madge rolls a 6-sided dice. The sides are labelled 1 to 6. Look at the 5 outcomes below. Outcome A, she rolls a 5. Outcome B, she rolls an even number. Outcome C, she rolls a 7. Outcome D, she does not roll a 3. Outcome E, she does not roll a 2. Which outcome is impossible? Give your answer as a letter. Write your answer in the space below. Well, let's go through each of the outcomes. Outcome A, she rolls a 5, where there are 6 numbers, and one of them is a 5, so it's got 1 chance in 6. Outcome B, she rolls an even number. Again, there are 6 numbers, 3 of them are even, so it's 3 chances out of 6, 50-50 chance. Outcome C, again there are 6 numbers, and the chances that she rolls on number 7 is 0, because there are no number 7s on the dice. Outcome D, again 6 numbers, and the chances that she does not roll a 3 is 5 chances in 6. And outcome E, again 6 numbers, and the chances that she does not roll a 2 is 5 chances in 6, because there's only 1 2, leaving 5 that aren't the number 2. So the first question wants to know which of the outcomes is impossible, and that was outcome C. Our next question, look again at the 5 outcomes above. Complete the sentence below by writing the correct letter in each of the spaces. Outcome something and outcome something are equally likely. Well, outcome D has 5 chances in 6, and outcome E has 5 chances in 6, so they're equally likely. William writes the numbers 1 to 20 on identical discs. The 20 discs are placed in a bag. He selects a disc at random. Look at the 5 outcomes below. Outcome A, William picks an even number. Outcome B, William picks a 2-digit number. Outcome C, William picks a number less than 5. Outcome D, William picks a multiple of 7. Outcome E, William picks the number 11. Put the 5 outcomes in order from least likely to most likely. One has been done for you. They've already sorted and labelled outcome E as being the least likely, so we don't need to worry about outcome E. Right, let's go back to outcome A. William picks an even number. Well, there are 20 numbers, and of the 20, 10 of them are even. If you count up in twos, there are 10 of them. Outcome B, William picks a 2-digit number. So we have the numbers from 10 up to 20, so all the way through to 20, and that's 11 numbers. So of the 20, 11 have 2 digits. Outcome C, William picks a number less than 5. So again, there are 20 numbers, and numbers less than 5, 4, 3, 2, and 1. So there are 4 of them. And outcome D, William picks a multiple of 7. So a multiple of 7, meaning they're in the 7 times tables. So 7, 14, 21, and we've already gone too far because we only go up to 20. So there are 2 of them. So of the 20 numbers, 2 of them are multiples of 7. Now that we've done all the working out, all we need to do is place our letters into the probability line at the bottom of the page. So the most likely event, the most likely outcome has the highest number, and that is outcome B. If I go to the next least likely with a low number, it would be outcome D. And moving up to the next big number would be the 4/20ths, which is outcome C. And our last one, the last outcome that we need to put into our probability line is A. A bag contains coloured counters. In the bag there are 10 counters. Here are the number of counters of each colour in the bag. So out of the 10, 5 are blue, 3 are red, 1 is yellow, and 1 is brown. Claire cannot see into the bag. She picks a counter from the bag. What is the probability of picking a blue counter? Give your answer by circling the correct fraction below. Well, let's go through each of the counters. So of the 10, 5 are blue. Of the 10, 3 are red. Of the 10, 1 is yellow. And of the 10, 1 is brown. But we are concerned with the blue counter. So 5/10 is the exact same as a half, 5 being half of 10. So half is the one that we need to circle. Each week, Harold picks one day at random to have takeaway food. Look at the 3 outcomes below. Outcome A, he has takeaway food on Friday. Outcome B, he does not have takeaway food on Thursday. Outcome C, he has takeaway food on Monday or Tuesday. Which outcome is most likely? Give your answer by writing a letter in the space below. Well, let's go through each of our statements. So, if he's picking food, takeaway food to have on each day of the week, so there are 7 days, and the outcome, the probability that he has food on a Friday, well, there's 1 Friday, so it's 1 chance in 7. Outcome B, again, there are 7 days, and outcome B states he does not have food on a Thursday, so that's 6 chances in 7, because there's 1 Thursday and 6 days where it isn't Thursday. And outcome C, again, there are 7 days, and the probability that he has food, takeaway food on Monday or Tuesday, 2 chances in 7. So the one that is most likely is outcome B. Next question. Look again at question 50, which is above. Which outcome is least likely? So least likely outcome is the smallest number, 1 chance in 7, so it's outcome A. The 7 numbers below are written on identical discs and placed in a bag. A disc is picked at random. So we have our 7 numbers here listed. Look at the 4 outcomes below. Outcome A, an even number is picked. Outcome B, an odd number is picked. Outcome C, a number greater than 100 is picked. Outcome D, a multiple of 50 is picked. Which 2 outcomes are equally likely? Write the correct letters in the spaces below. Well, let's go through each of the outcomes. So there are 7 numbers. So this first outcome A is concerned with even numbers. So let's see how many even numbers we have. 2, 4, 100. So we have 3 even numbers. Outcome B. Again, there are 7 numbers. This time we're concerned with the odd numbers, an odd number being picked. So let's see how many odd numbers we have. 5, 11, 13, and 153. So we have 4 odd numbers. Outcome C. Again, there are 7 numbers, and this time the chances of picking a number that's greater than 100, where there only is one of them. And outcome D, again there are 7 numbers, and the chances of picking a multiple of 50, meaning it's in the 50 times tables, we've only got one, it's 100. So which two outcomes are equally likely? Well, we can see that 1/7 and 1/7 pops up twice. Outcome C and outcome D. A pencil case contains 13 pens. The number of pens of each colour is given below. 5 black, 4 blue, 1 red, 2 green and 1 purple. A pen is selected at random. Look at the 5 outcomes below. Outcome A, the pen is black. Outcome B, the pen is blue. Outcome C, the pen is red or purple. Outcome D, the pen is not black. Outcome E, the pen is red. Write the outcomes below in order from least likely to most likely, and one has been done for you. So they've already placed outcome E onto the probability line, so we can remove it. Right, let's look at outcome A. So there are 13 pens, and the probability that the black one is picked is 5 out of 13. Outcome B, there are 13 pens. The probability that a blue pen is picked is 4 chances in 13. Outcome C, again, there are 13 pens. The probability that you pick a red or a purple, so we've got to add red and purple, so there's 2, because there's 1 red pen and 1 purple pen. And outcome E, again, we have 13 pens, and the probability that a black is not picked, well, if there are 5 black, it means there are 8 not black. So 8 chances in 13. Now that we've done all the working out, we can place the letters onto the probability line. Well, the outcome that is most likely has the highest number. So that is outcome D. If we go back down to the least likely, so then we're looking for the small numbers. So outcome C has 2 chances in 13. Again, we're getting bigger as we go up our probability line. The next statement would be outcome B. It's got 4 chances. And then outcome A, it's 5 chances in 13. Lauren has 35 photos on her computer. Each photo is of one member of her family. There are 10 photos of her mother, 5 of her father, 15 photos of her brother, and 5 photos of her sister. Her computer picks a photo at random. Look at the 5 outcomes below. Outcome A. When the computer picks one at random, it's a photo of her mother. Outcome B, it is a photo of her father. Outcome C, it is not a photo of her sister. Outcome D, it is a photo of her brother or her sister. And outcome E, it is not a photo of her mother. Write the outcomes in order from least likely to most likely. One has been done for you. So they've already placed outcome B into the probability line, so we don't have to worry about it. Let's look at outcome A. So there are 35 photos. And of the photos, there are 10 of her mother. So the chances of picking a photo of her mother is 10 chances in 35. Outcome C then. Again, we have 35 photos. And this time outcome C, it is not a photo of her sister. So there are 5 photos of her sister. So that means there are 30 that are not of her sister. Outcome D, again we have 35 photos. It is a photo of her brother or her sister. Well, there are 15 of her brother and 5 of her sister. So we need to add those two. Because there's 15 of her brother, 5 of her sister, giving us 20 chances in 35. And outcome E, again we have 35 photos, and we're this time focusing on not picking a photo of her mother. Well, there is 10 of her mother, meaning there's 25 that are not of her mother. Now we've done all the working out, we can place the letters on a probability line. So let's look for the most likely, so the highest number, and we can see that it's outcome C. 35, and there's 35 photos, and we have 30 of them are not of her sister. The next one, if we go to the smallest, the least likely, would be outcome A, 10 chances, 35. Again, let's move along, getting our numbers bigger as we move up the probability line. Outcome D would be next, and the last outcome, E, would be like so on the probability line. Look at the 6 cards below. Each has a number on it. These cards are shuffled and placed face down on a table so that the number on each card cannot be seen. So we've got 6 cards, 12, 3, 6, 24, 2 and 4. One card is picked at random and turned over. Look at the following 5 statements. A. There is an even number on the card. B. There is a number less than 2 on the card. C. There is a factor of 24 on the card. D. There is a multiple of 6 on the card. E. There is a prime number on the card. Write the letters A to E in the circles below to match a probability to each statement. 2 have been done for you. They've already done D and C, so we don't need to worry ourselves with those 2 statements. So let's look at statement A. So there are 6 cards, and this time we're looking at how many of them are even numbers. Well, we've got 12, 6, 24, 2 and 4. So 5 of them have even numbers. Statement B, of the 6 cards, this time we're looking for where there is a number less than 2, and there are none of them because 2 is the smallest number up there. And E, of the 6 cards, this time we're looking at how many of them have a prime number on the card. So a prime number can only be divided by itself and 1, and we've got 2 and we've got 3. So there are 2 numbers that are prime numbers. Right, let's sort them now onto our probability line. So the statement that is impossible, meaning there are 0 chances in 6, is statement B. We're left with 2 now. The one that is most likely, it's not certain, but it's got a high number, is statement A. And our last statement, statement E, is down at the unlikely end of the probability line. 4 bags contain coloured counters. The bags are labelled A, B, C and D. The contents of the 4 bags are shown below. So bag A has 5 black counters, 7 white and 8 blue. Bag B, we can see what's in it. Bag C and bag D. Jenny is asked to take 1 counter from each bag without looking into the bag. From which bag is she most likely to take a blue counter? Write your answer A, B, C or D in the space below. Let's look at bag A first. So in bag A there are 20 counters in total. And you find that by adding up the 5, 7 and 8. So 20 counters in total. And of the 20 counters, 8 are blue. Bag B, there are 10 counters in total. And of the 10, 2 are blue. Bag C, there are 5 counters in total. And of the 5, 3 are blue. And bag D, again some mental maths, you add up those numbers, you'll find that 15 of the counters are in the bag and 6 of them are blue. At the minute this doesn't help us enormously because all of the denominators, the bottom number in the fractions, is different. But let's turn them into percentages and see which of the bags give us a best chance of picking a blue counter. So back to bag A. 8 twentieths is the same as 4 tenths. And 4 tenths is just 40%. Bag B, 2 tenths is just 20%. Bag C, 3 fifths is the same as 6 tenths. We double each of them, which is 60%. And bag D is tricky. First, let's turn it into 30ths. So if we double the bottom to get 30, we double the top, because we need to do the same to the top and the bottom, we get 12. Now it's in 30ths, we can put it back into tenths, the same as the others. So I divide the 30 by 3 to get down to 10. So I divide the top by 3 to get 4, meaning that is 40%. 4 tenths is 40%. Now we've got all the percentages, and we have them all in tenths. It's quite obvious and easy to see The bag C is the greatest percentage, the greatest probability of choosing a blue counter. Nisha is playing a game using a single dice. The numbers 1 to 6 are marked on the dice. Nisha throws the dice. His score is 2. Only one of the 3 statements below is true. Tick the correct statement. Statement 1. Nisha's chances of scoring a 2 is evens. Well, that's not going to be true, because if it were to be evens, there are 3 chances in 6. But his chance of scoring a 2 is only 1 chance in 6. So this is not one of our true statements. Nisha's chances of scoring a 2 is less than evens. So again, his chances of scoring a 2 is 1 chance in 6. And that indeed is less than evens, because evens is 3 chances in 6. And let's just check our last statement. Nisha's chances of scoring a 2 is more than evens. Well, it is not. Chances of scoring a 2 is 1 in 6. Chances of getting an even number is 3 in 6. So our middle statement indeed is the correct one.